In this video, we are going to discuss some MCQ questions based on statistics. Now, the first question says that mean deviation for n observations, x1, x2, up to xn is given in x bar. Then what will be the correct formula for the mean deviation? Now, if you look into the different formulas that we have for finding the mean deviations, I think this is the first one itself. Now look into this formula. This is for finding the mean deviation about the mean or median. So here M stands for the mean or median. And as we know that the mean is also denoted by X bar. So we'll say that if you compare the closest one, yeah, this is the mean deviation. So the only difference here is that I have written M over here, which stands for the mean or median. That's a common letter, while X bar also stands for mean. The next question, that is question number 2, it says the standard deviations of these observations. As you can see, these are discrete observations, and we have to look for the formula for standard deviation of discrete observations. Yes, this is what the formula for finding the calculation of variance and standard deviation. So we are looking for just the standard deviation here. Now this is for individual series. For as you can see here, the number of observation 1, 2, 3, 4, 5, 6, 7, right? So we can say n is equal to 7 here. N is equal to 7. Now we have to find sigma xi. So sigma xi is what? The sum of these number, that is 6 plus 5 plus 9 plus 13 plus 12 plus 8 plus 10. This comes out to be 63. Then we have to get sigma xi square. This is sigma xi square. That means we have to find 6 square, 5 square, plus 9 square, up to 10 square. I've already done the calculation with calculator. Now to shorten the video, this is coming as 619. Now we can find this standard deviation here by replacing these symbols with their values. So we have sigma xi square, as you can see it is. We have calculated sigma xi square as 619. 619 divided by the number of observations, which is 7 in this case, minus sigma xi, which is 63 over 7, right? So 63 over 7 whole square. Now you can even reduce it. That comes out to be 9. So if you do the calculation here and finding the square root, you will get 15 under root 52 over 7. So we'll say this is the correct answer for this. The third question is that x1, x2 up to xn be n observation and xi be the arithmetic mean, x bar is the arithmetic mean, then the formula for the standard deviations. So when you have this information available, let's check for the formulas. We have the different formulas for finding standard deviation. As I can see, this match this only. So we have x bar here, as you can see, and n. Now, one more thing. This is for the standard deviation, and this is for finding the variance. Now we are looking for the standard deviation. So what you can observe here, you can observe one thing, that this 1 by n can be written here also, right? You can write this as 1 by n. Writing 1 by n over here is same. So you can see from here only that this cannot be correct, as you can see from the figure itself. And here there is no under root. That signifies that it cannot be a standard deviation. Over here, this is the square of the mean. Well, this is actually should be xi minus x bar whole square. Well, x bar is the mean and xi is the individual, the values of x. So we'll say that the closest answer. Yeah. So this is the actual formula. So writing over n over here is same as writing 1 over n here. The next question is to find the mean deviation of the numbers from the mean. So what we know how to find out the mean deviation from the numbers. First of all, we'll find out the mean here. So mean is what? Sum of all observation divided by the number of observations. So 3 plus 4 plus 5 plus 6 plus 7, that divided by 5. So this is 25 divided by 5 will give you, this is 25 divided by 5, that is equal to 5. So we got x bar, that is the mean here. Now we have to find the deviation. And how do we find the deviation? This is the formula is xi minus x bar, right? So if you calculate xi, which is 3 minus x bar whole modulus plus 4 xi minus x bar whole modulus plus xi minus x bar whole modulus plus same way xi minus x bar whole modulus plus xi, which is 7 minus x bar, which is 5 whole modulus. So if you calculate, this comes out to be 2 from here. This is 1 plus 0 plus 1 plus 2. So that is 2 plus 2, 4 plus 2, 6. So this is 6 divided by 2. Sorry, divided, but there's division of 5. 5 that I've, this is all divided by 5, right? So this divided by 5, and that comes out to be 12 over, sorry, this is how much? 6 over 5. 6 over 5 is equal to 1.2. So we'll say that C is the correct option in this case. The sixth MCQ says that if V is the variance and this is the symbol for standard deviation, then the relation between these two. Now, what we know here that we know that for calculating standard deviation, we find the square root of variance, right? That's what we do. If this is the variance, if this is the variance, the square root will give you the standard deviation. So as I can see, this not relation is not given as an option. So if I do squaring both sides, I can say that this should be the correct. So the correct answer should be option C. In question number 7, we have to find the standard deviation of first 10 natural number. So what I will say that instead, whether it's a 10 or 11 or 13 or 17 or 18, whatever be the number, we can use a general formula for this. So let's say, for example, in case of n, I'm going to derive one formula where the first n natural number. So you know that this is the formula which is used for sum of first n natural number. Sorry, this is the formula here for the standard deviation. So standard deviation is equal to, if I place one whole under root, so I placed a whole under root. First, I'm going to calculate this part. So this is what? Sum of first square of n natural numbers. So it's going to be 1 square plus 2 square plus 3 square dot 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 up to n square, and that divided by n. Minus, there's a bracket over here. Let me place the bracket. This is the sum of first n natural number. So this is 1 plus 2 plus 3 plus 4 dot dot dot. This is n divided by n, and there is a square over it. Now, what do we know as a sum of squares of n natural number? We have a formula that is n into n plus 1 into 2n plus 1, that divided by 6. And we have already an n over here. Minus this formula for finding the sum of first n natural number is what? n plus 1 divided by 2. And we have an n here. And we have to get the square of this as well. And there is a whole under root. Now, if we reduce this here, n and n get cancelled, this get cancelled. Now, from here, we can see that if you plug in n, whatever is your n, as in case of this, we are taking 10 here. So if I place 10 over here, let's calculate here what we are getting. 10 plus 1 is 11. 11, and this is placing 21, that divided by 6, minus what is 10 plus 1? 11. 11 by, we have a square here, so I can write, okay, I can write this as 11 square 121 and 2 square is 4. Now for further simplification, I can see this is getting cancelled. 3 2 times and 3 3 times. So finally we'll get what? 33 upon 2 33. I need space, so I'll keep smaller space. This is 33 over 2 minus 121 by 4. I can see an error has taken place. This is, while cancelling, this is 3 2 times and there is 377 times. That's why I was looking, that's coming smaller. So this is 77 over 2 minus 121 by 2. So if I do further calculation, this is 4. If I take LCM, it's going to be 77 into 2, that is 154. 154 minus 121, that divided by 4. So it's if I subtract 121 from here, that's we are getting 33 under root 33 over 4. 4 under root is 2. The thing is that we have to get the under root because I can see we need the answer in decimal. So under root 33 is what we have to calculate. That comes out to be 5.74 that divided by 2. So if I divide it by 2, I'll get 2.87. So it is 2.87. So what you have to remember that if you have to place n as any natural number, we can first of all derive this relation, or you can remember this as a formula and place whatever the value of n it is. The next question is to find the mean deviation of these data from the mean. So we are going to use this formula where here m stands for the mean. I used a common symbol for mean and median. You can, as of now, you can replace this with x bar. So we have to get, first of all, I can see n is how much? 1, 2, 3, 4, 5, 6, 7. So n is 7. Let's get x bar first, which is the mean here. That is 3 plus 10 plus 10 plus 4 plus 7 plus 10 plus 5. That divided with the number of observation, which is 7. So this is coming 20, 30, 49. That is 49 divided by 7. So if I divide, I'm getting 7. So we got x bar as 7. So now we have to get use this formula for finding the deviation. This is 1 over n, and n is 7. And the summation here, that means xi minus x bar, xi minus x bar. So xi minus x bar. So this is whole modulus. So I'll write 4 here, right? And 4 plus this minus this whole modulus is 3. This minus this, the difference is 3 again. 4 minus 7, the difference, which is 3 again. 7 and 7, that's 0. Then once again, we have 3. And finally, it is the difference, which is 2. That is equal to what? So it's coming 3, 1, 2, 3, 4. 4 into that is 12 plus 6, that is 18. So that is 18 divided by 7. So if I divide 18 by 7, we are going to get 2.57. It's 2.57. So this is the correct answer for the 8th part. The next is an assertion reasoning. It says in order to find the dispersion of a value from mean, we take the measures of dispersion as absolute. We take absolutes, right? We have an absolute sign here for the measures of dispersion. And the reason says, well, the assertion is definitely correct. We take an absolute value of the dispersion. Now, the reason says that sum of the deviation from the mean x bar is 0. Yeah, the reason is also correct. As you know, in order to find the mean, we must obtain the sum of the deviation. But we know that the measure in the measures of central tendency, which lies between a maximum or minimum values for this set of observations. In fact, some of the deviations are positive, some negative. Like say, for example, if I find the deviation, like I have a set of data, and if I find xi minus x bar, will have some values in negative, others positive altogether. And so thus the sum of the deviations will vanish, right? It will come as 0. And that is the reason why we use an absolute value over here. So it's a correct assertion, correct reason. And the reason is also the correct explanation of the assertion. In question number 2, it's an assertion reasoning. It says the data given here, it says the variance of the data is this and its standard deviation is this. Well, we know that standard deviation is the square root of the variance, and I can see that the square root of this is equal to this. So the reason is correct here. Now check here that we have to find out the variance of this by actual calculation. So for that, you are going to use this formula, any of them. That's we are finding variance, right? So we'll be using this, we'll be applying this. So you have to make 3 column here. In the next column, you'll be finding xi minus x bar, right? You'll be writing xi minus x bar here. And how will you calculate x bar? X bar is clearly that is the mean, which is 4 plus 8 plus 11 plus 32, whatever it comes, divided by 1, 2, 3, 4, 5, 6, 7, 7. So first you find out xi, x bar, and then you find out this, that is xi minus x bar square. Once you calculate this, these values here, add them and plug in it on this formula to check whether the variance is this or not. In case if you are getting the correct answer as the variance, then here the reason is also correct, but not the correct explanation. In that case, it should be B. Or if the variance is not coming as 45.8, you will say D, as here the assertion is not correct. In this question, it says the variance of first 5 multiple of 6 is 70. And the mean deviation for formula, I can see the mean deviation formula is correct. That is 1 over n into xi minus x bar. So we need to cross-check by finding the mean. For that, I first find the mean, which is x bar is equal to first 5 multiples of 6 is 6, 12, 18, 24, 30. That divided by 5. Now for calculation, I'm taking 6 common. That will give you 1 plus 2 plus 3 plus 4 plus 5. That divided by 5. Now this is x bar is equal to, this is 5, 9, 15. So 6 into 15 over 5. So x bar comes out to be 18. Now in the next part, I'm going to find out the mean deviation about the mean deviation. So this is 1 by 5 as n xi. I'm using this relation, right? Yeah, I'm using this. So this is xi minus x bar whole square. So it is 6 minus 18 whole square is always positive, plus 12 minus 18 whole square plus 18 minus 18 whole square plus 24 minus 18 whole square and plus 30 minus 18 whole square. So this is equal to 1 over 5. This is coming 12. 12 square is 144 plus will give you 6 square is 36. 0 square is 0. So we may not write. This is again 36. From here it is 12. Whole square is 144. So this is 1 over 5. It is 180, 180, 360. So that is 360. If I reduce 360 by, this is, yeah, 360, right? So this is 360. If I reduce by 5, it is coming 18 times or 72. So this comes out to be 72. So when you compare with this formula for calculation of variance, Using this formula, what we got as 72, but over here it's saying 70. So therefore, assertion is wrong, reason is correct. In the next question, we have to find the standard deviation for first 10 natural numbers.